Gregory Wrightstone is a geologist, best-selling author of Inconvenient Facts. Love that title, playing off of Inconvenient Truth, right? That was nothing even close to truth. And A Very Convenient Warming. He's an expert reviewer for the Intergovernmental Panel on Climate Change. Mr. Wrightstone has authored or co-authored more than 200 papers, publications, and commentaries concerning climate change and energy. Wow. And executive director of the CO2 Coalition, Mr. Wrightstone is a strong proponent of the scientific process. Don't let people tell you that scientific consensus, that has nothing to do with the scientific process. Please give a hearty welcome to Gregory Wrightstone.
All right, thank you very much. I walk around, I can't stand still. Hopefully I don't fall off the edge here. Let me before we get started, we have some free, yes, I said free publications out front that are two of our top new reports, Challenging Net Zero with Science, and another one, Climate Change and Health. It's actually, we'll talk a little bit about this. It was in the Federal Record and we'll talk about the endangerment finding. But those two are free. We encourage you to go get them. And so today, the title is Life in Oregon is Getting Better, Good and Getting Better. And that's the overall theme that I want you to focus on. My first book, Inconvenient Facts, I knew that as a geologist, some of what we were being told about climate change was just incorrect. Others I suspected to be wrong. And so that led me to my own personal search for the truth in the publication of my first book. But we've gone beyond that there is no climate crisis. What we'll go through today is that not only is there not a climate crisis, but by almost every metric we look at, Earth's ecosystems are thriving and prospering, and humanity is benefiting from modest warming and more CO2. We should celebrate that. Who is the CO2 Coalition? Gentleman in the top left. I need to get the microphone closer, I'm told. Those are in hand signals. So there we go. And so the gentleman at the top left, Dr. Patrick Moore, he was an environmental from the old school when environmentalist really meant something and it wasn't a pejorative. He was a co-founder of Greenpeace. He was one of the guys in the Zodiac boats challenging the whale ships. They shot harpoons over him. He was a true environmentalist. He left Greenpeace when they went astray, and he now sits on our board of directors. Gentleman at the top right, just to give you an idea of the quality of the membership, Dr. John Clauser, 2022 Nobel laureate in physics. Bottom left, Dr. William Happer, our co-founder and chair. I work with Dr. Happer on a daily basis. He is the most humble, wise, brilliant man you will ever meet. And I'm just blessed to have him, work with him every day. But that's who we are. Actually more than 200 of the top scientists in the world, including one right here you might know of, Noah Robinson, who is one of our newest members. And he still owes me a headshot for our website, so I'm going to have to come after you for that, Noah. And so the endangerment finding, let's talk about this. It's happening this is all happening right now. Back in 2007, Massachusetts versus EPA, the Supreme Court ruled horribly, wrongly, we're going to hopefully correct that carbon dioxide or CO2 is a pollutant. It could be regulated using the Clean Air Act. A year later, the Obama EPA issued what they called the endangerment finding, again, regulating carbon dioxide. And what this has done is led to regulations of just about everything that you use in your home, from ceiling fans, your cars, what kind of car you can drive, what kind of a dishwasher you're allowed to buy. They want you to buy what they call efficient appliances, for example. And so when I tell you I'm pro-choice, just don't boo me. I'm pro-choice because I believe that you should have the choice of what kind of dishwasher to buy, what kind of washing machine to buy. They call the dishwashers that you buy today efficient, but if you go to buy a dishwasher, it's going to take you 2.5 to 4 hours per cycle and your dishes still are not clean. Their definition of efficient is a lot different than my wife's definition. Her definition of efficient dishwasher is one that gets it clean, dry, in 45 minutes or less. Now that's an efficient, but you can't buy those, and because of the things like the endangerment finding. And so just a little over a month ago, Lee Zeldin announced that the EPA was repealing the rescission of the endangerment finding. A huge, huge move on that. Later the same day, there were a consortium of environmental groups with NRDC, the Greenpeace, all the rest of them. They combined on the same day and appealed the repeal before the DC Court of Appeals. And then just last Friday, we made the big decision of the CO2 Coalition. We've employed the law firm in DC, Baker Hendershot, that will be filing. We decided to fight that repeal, and it's a big decision for us. Very expensive law firm. We filed that on Friday, and we're going to be fighting them in the DC Circuit Court of Appeals. We'll probably lose there at some point over the next year, and then it will end up before the Supreme Court. So we and our team that we've elected to do this, to go ahead, and we'll probably be arguing this in the Supreme Court, fighting for you and the American people. And it's actually, this is we've talked, it's a big, expensive decision for us to do this, but it's almost as if the CO2 Coalition was built specially for a moment like this, for a case just like this. So we're going to be working for you. That's our filing. And all of this goes around this absolute nonsense that carbon dioxide is a pollutant. A lot of what you'll see today is from my newest book, A Very Convenient Warming. They have them at a discount price of $10 out in the lobby there. Please help yourself. But a lot of this is drawn from this today. And what I want you to come away from today is that there is no climate crisis. There just isn't. And life is good and getting better. You'll see the billboard here. We have a billboard campaign we run. This was from the Pennsylvania Turnpike. And as people were driving past, they were, heads were exploding from these these environmentalists. And I think it would look really good here in Grants Pass if you had. So it's not that expensive to do a billboard campaign. So you've heard of the 97% consensus of the scientists that say that global warming is dangerous and it's caused by us. It's caused by our emissions. So one of my favorite quotes is from Michael Crichton, who said, there's no such thing as consensus science. If it's science, it isn't consensus. And if it's consensus, it isn't science. But my favorite quote is from Richard Feynman, the noted Nobel laureate in physics, who stated, I'd rather have questions, think about this, I would rather have questions that can't be answered than answers that can't be questioned. And that's what we have today. They're telling us what the answer is, and you dare not speak up. You dare not have any science like we do at the CO2 Coalition. You dare not argue the case. And that's just not how science works. And so in climate science, there is some agreement here. Number one, CO2 is increasing. Yes, it is. CO2 is a greenhouse gas, and it has some warming effect, just we believe not very much. And temperature has risen about 1.5 degrees since the Industrial Revolution. But there is great disagreement on what is causing the temperature rise. You'll be told by the government institutions that it's CO2 increases causing the temperature rise, whereas we will talk today about natural forces driving that. And also the big disagreement here is the increase in temperature and more CO2, is that beneficial or harmful? And I'm hopefully convince you one of those as we go through here. But I think we have to let's take a look at carbon dioxide through time as we look here. And We started measuring CO2 in 1958 at the Mauna Loa Observatory. And so this is a chart, and I want you to see, as you're going through here today, these charts, the oldest dates are on the left, going to the more recent dates on the right. If it's in blue, it's carbon dioxide. If it's red, it's temperature. So just set you up for what you're going to see here. So we've had a gradual, nearly linear increase in carbon dioxide. And if we go back to this is a chart going back to 1759, which predates the Industrial Revolution. You can see the key here is that look in about the middle of the 20th century, in that post-World War II economic boom is when we started really adding a lot of CO2 to the atmosphere. So if carbon dioxide is going to drive temperatures, that's when we should see it, any effect of that. We also know that during the warm periods, we're in 100,000 year glacial cycles. We usually have about 90,000 years of a glacial advance, 10 or 11 or 12,000 years of warm, thankfully warm period like we're in right now. And during the warm periods, oceans expel carbon dioxide, cold oceans absorb it. And so if you see the red dot way up there in the top right, that's where we are today. Something's different over the last 400,000 years today. And I will argue that what's different is we're using a lot of fossil fuels and liberating lots of CO2, and that's a good thing. If we look at the last 140 million years of CO2 data, we'll see that we've been in nearly a linear decline of carbon dioxide in the atmosphere. The average throughout Earth's history is 2,600 parts per million. We're a little over 400 today. So the average is 6.5 times what we are today. And so if you look at it in the long term, we're actually CO2 impoverished. We don't have too much CO2. We don't have enough. And indeed, that red line at the bottom is what I call the line of death. And that's the limit, the lower limit, 150 parts per million, where plant life can't survive. We nearly got there at the end of in the middle of the last glacial advance. We got to 182 parts per million, almost got to that. If we ever reach that low limit, that would be a true climate crisis and catastrophe. One of the other things that you may have heard, there's some false information out there that's passed off as facts that Mount Pinatubo, volcano, big volcanic eruptions, Pinatubo in particular, is put more CO2 in the atmosphere than humans have ever put out and throughout our entire existence. It's just false. It is absolutely false. And if we look at the blue line is the model, what we should have seen for CO2, atmospheric CO2. The red line is what showed up. We actually had a decrease in atmospheric CO2 after Pinatubo, which is fascinating. Dr. Roy Spencer, we've talked, he's conjectured that it's because when the volcano erupted, it puts lots of sulfates into the atmosphere stratosphere. And he says that instead of the sunlight coming directly in, straight from the sun, those sulfates reflected the sun rays. So now we've got sun reflected from all kinds of angles, and it can penetrate deeper into the forests and jungles. And that's the best explanation I've been able to find. What does that do? It increases photosynthesis. When you're increasing photosynthesis, you're sucking a lot more CO2 out of the atmosphere. But again, this is just proof it's not volcanoes. It's probably from us and our emissions of CO2 from using fossil fuels. And the blue line here too is the accumulated carbon dioxide, what it should have been in the atmosphere from our emissions. The blue dashed line below is what's actually showed up in the atmosphere. So we're actually emitting twice as much carbon dioxide as what shows up in the atmosphere. Well, how can that be? Well, it's because it's accelerating photosynthesis. The more CO2, the quicker the plants grow, the more they suck the CO2 out of the atmosphere. So there are huge amounts of CO2 being used from vegetation, expanding forests, shrinking deserts. And we'll talk about that in a little bit. With agricultural productivity is accelerating greatly because of more CO2. So we're using that CO2 as a huge benefit. And again, we're told that carbon dioxide is driving temperatures. And indeed, if you look at the last 50 or 70 years, I'm showing here, again, remember, red is temperature, blue is CO2. Last 50 years, there has been a correlation, more or less, with rising CO2 and rising temperatures. But I'll remind you, the correlation is not causation. And what I had some fun with, I had one of my scientists, he compares, this is a chart here comparing the Standard & Poor's price index of stocks in black and temperature in red. And so there's a great website, some of you may have seen, it's called Spurious Correlations. And it's a fun website because they correlate various things. Like there's a really good correlation between ice cream sales and shark attacks, of course. Just things like that there's no causation, but there's correlation. So let's take a look at temperature in a longer perspective, which is what we need. Remember I said in the middle of the 20th century, in that post-World War II economic boom, as we started adding a lot of CO2. All right, well, this chart here, again, red temperature, blue CO2. Just as we started adding a lot of CO2 to the atmosphere, we went into a 33-year cooling period. When I was in school, geology in the late 70s, we were being told that we might be going into the next ice age. We had 33 years of cooling. Putting yourself back into 78, 77, we had no idea when it was going to end. It might go for another 50 years and we'd be going into the next ice age. So we had cooling as CO2's rising. This is the longest thermometer-based temperature record in the world. And what we're seeing here again in red is temperature. We see that the warming trend that we're in today started more than 300 years ago. 150 or 200 years before the first Model T rolled off the assembly line, before we started adding CO2, the warming started long before that. And look at the same graph, a little bit different with an expanded y-axis. This is the same graph showing comparison of CO2 to temperature. I don't know about you, I don't see any correlation there. And again, a little bit longer term, we look over the last 1,000 years, go back to we're in a warming trend, look back to the last big warm trend. It was called the medieval warm period. Again, that occurred at very low CO2 levels. And then we had the Little Ice Age that occurred, that you can see there around 1600, 1700 is when it was the lowest temperatures. Probably the lowest temperatures of the last 10,000 years. And then just even a longer term, going back 8,000 years, we see over 8,000 years, we saw a gradual increase in carbon dioxide and a gradual decrease in temperature. Again, we see just an opposite correlation between CO2 and temperature. And what they're trying to do, they're trying to talk us into spending trillions of dollars to stop temperature from rising from CO2 when there's really a very good argument saying that's not what's controlling temperatures. And also we see that glaciers, people say, well, glaciers are retreating. That's proof of global warming. Yeah, it is. Glaciers retreat when it gets warm. We're in a warming trend. That's what they do. But when did it start? Glaciers started retreating in the early 1800s. Again, long before we started adding CO2 to the atmosphere. And this is a combination of 169 glaciers from around the world. And this confirms that glaciers started retreating in the early 1800s. Now, this is a picture of my wife and I took a cruise, went up into Alaska, and this is us in Glacier Bay, and we were in front of the John Muir Glacier, and the captain of the ship came on, and he said, this glacier's retreating. This is proof of climate change and global warming, and I was freaking out. my wife, she's like grabbing me, settle down, Greg, settle down, you know. I was screaming at the captain. People were going like, they were looking at me. I said, no. And so I took a look at, this is Glacier Bay, and the Gulf of Alaska is just down at the bottom. Back in 1760, there was no Glacier Bay. It was completely full of ice. And starting in the late 1700s, it started retreating. And you can see the dates. And that's where the glacier, the face of that glacier was 1845, 1880, 1948. And so 90% of the glacier retreat in Glacier Bay, where you just saw my wife and I, and 90% of that occurred before 1960. But yet they don't want you to know that. They will not tell you that. It's inconvenient facts for them. And again, what was causing the retreat of glaciers in the early 1800s and late 1700s? It wasn't CO2. And so I went back through and got some Oregon-specific data for you, because that's what I do for you, and I put this together. And so we've got some recent Oregon data to what's actually happening here in Oregon. Again, red temperature, blue CO2. And so this is the average mean temperature in degrees Fahrenheit. And we see in Oregon, we've increased a little over 1 degree Fahrenheit of warming. All of these charts go back to about 1890 or 1895. So we've got we're showing 120 plus years of data, 130 years of data here to show what's actually going on with temperatures. And so this is nothing alarming, 1.2 degrees Fahrenheit. We see that between 10 a.m. and noon most days, don't we? Or 11 a.m. and noon most days. And the other thing we look at, they say, oh, but it's the heat waves. The maximum temperatures in Oregon are just terrible. And well, this is maximum temperatures, again, going back to 1890. And we see that the maximum temperatures usually, not always, but they usually occur in the mid to late afternoon, just like the low temperatures usually at some point at night. But the maximum temperatures in Oregon, again, have only increased about 1 degree Fahrenheit, which is nothing alarming. And one of the other things we see, and this is really impactful, is in Oregon here, we've seen that the nighttime temperatures, the lowest temperatures, have been lessening. This is the number of days, or actually nights, below 20 degrees Fahrenheit in Oregon. And we see that that's in other words, nighttime coldest temperatures have been increasing. That's good. That's really good. And think about that. What this means is it's the most important item here when we talk about low temperatures at night. It means that growing seasons are lengthening. Growing seasons are lengthening in the contiguous United States, have increased nearly 2 weeks since 1900. And what does that mean? Here in Oregon, there are a lot of fruit orchards, aren't there? If you own a fruit orchard, what do you fear the most? It's a late spring killing frost. It'll ruin your year. It'll knock you out, put you down. And because of global warming, and we are warming, the killing frosts end earlier in the spring and arrive later in the fall. That's huge, huge, huge for agriculture. You can get more plantings in. And again, growing season has lengthened nearly 2 weeks since 1900. And again, there's no relationship here to CO2. And so Monday, I got up, and I'm putting the presentation together that you're looking at here, and my news feed came on, and there was a once in a 4,433-year heat wave is hitting the western United States, including Medford, Oregon. This was the map that they showed. And I said, oh my God, it's like going from the frying pan into the fire. I'm going to Medford, Oregon, telling them there's no climate crisis, and it's the worst heat wave in 4,000 years? How am I going to explain that? And so I said, oh, this is bad. How am I going to explain that? And so I went to AccuWeather and I looked, and I said that, the 4-day forecast from Monday was a high of the next 4 days of 72 and a low of 33. This is how they distort and provide disinformation to you. Was there a heat wave earlier in the week in some parts of the West? Yes. But this isn't correct, because you live, it's not Medford, you're in Grants Pass, granted, but there's no heat wave. But they told you, everyone else that's not living here does not know that. And the other thing what else when they talk about heat waves? About this one on Monday, they always reference Phoenix, Arizona. I want you to look for this. They always reference Phoenix, Arizona. And why do they do that? Because the Sky Harbor Airport is one of the worst of the weather stations for the urban heat island effect. And if you can just search for this, Google Sky Harbor Airport weather or temperature and urban heat island. And you'll find that it's often, that station reports 15 degrees Fahrenheit temperatures hotter than the surrounding stations that aren't as built up. And that's because that station is right at the runway. And you can see spikes of heat through the day as the jets are landing and taking off. And that's why they will reference Phoenix. I want you to look for that. And when you hear the next time, you go, Phoenix, Arizona, they're lying to me. Because they're using Sky Harbor Airport data that's just false. So we'll look here, Oregon days with temperatures above 100 degrees Fahrenheit. There's been there's no statistically increase of really hot days in Oregon. Again, this goes back to 1890. So if climate change was increasing really hot days, it would show up in this data. And this is the United States Historical Climate Network data, which is a select group of the stations that try to get some of this urban heat island, the really bad stations are removed. And so look at this. The other thing that I was reading earlier in this week, they were claiming this heat wave was leading to droughts in the western Northwest and the western United States. It was going to affect agricultural productivity. It's going to be terrible. Yes, the snowpack is low this year and I wish I had the snow date. I wish I had done that to show you what the snow date is, because again, we can look at the long-term data. But again, looking at this in Oregon, as we see across the United States, precipitation data changes year to year. Some years you get a lot of rain, a lot of precipitation, others not so much. But again, there's been no statistical trend in precipitation in Oregon or the United States. We see most of the states, though, we see a slight increase in precipitation, which is really good for agriculture. And also we take a look at the Palmer drought severity. This shows how Oregon's drought index. Again, there's been no statistical trend either up or down for drought. Again, going back to 1895. And what would Oregon, like many of the other blue states, are actively trying to rein in carbon dioxide. Rein in, stop your fossil fuel use. Planning to spend trillions of dollars to change the climate and to lower the temperature of the atmosphere. What would we do if Oregon was able to go to net zero, completely zero out all of their carbon dioxide emissions? What warming would be averted? And if we look over here, I've got circled 0.001, that's 1/1000th of a degree Fahrenheit by the year 2100, is what no more emissions of CO2. That's the effect it would have. Is that worth reining in your freedoms? No, it's not. 1/1000th of it, it's well below anything we can measure. It's closer to zero than it is to anything we can measure. And that's what we have to look at, is what effect would we get from decreasing CO2? It's imperceptible. And so I like this statement. global warming saves lives. And I'm saying, well, how can you say that? I'll show you. Global warming will save a lot, maybe millions of lives. This is the largest study of temperature-related deaths, temperature-related mortality that was done. Dr. Antonio Gasparini looked at 74 million temperature-related deaths. Each one of those bars are from 14 countries, from warm countries to cold countries. The blue bars are cold-related deaths, and the red bars are heat-related deaths. And what's interesting here, the light blue is moderate cold. I'm often asked, well, why does moderate cold kill more people, a lot more than extreme cold? And that's because, think about it, moderate cold occurs every single winter. Every winter, and for most of the winter, is moderately cold. But extreme cold, we may not get really extreme cold. You might go many years without extreme cold. But the point here, they found that 20 times as many people die from cold-related deaths as from heat-related deaths. And I want you to, if you know anything about charts, this next chart, you just bear with me. This is a recent study. The authors of this study found, and you could tell what their conclusion was completely contrary to what they hoped. And their finding was that 10 times as many people died from cold as from heat. And this is the chart that they put up. And something bothered me. I said, something's wrong with this. So I took a good look at it. And the x-axis at the bottom here, look, the cold-related deaths, the x-axis was 0 to 250. The heat-related deaths, 0 to 50. So what they did was exaggerate 5 times on the chart, heat-related to cold-related deaths. Do you follow me? So I said, okay, I'm going to make my own chart using the actual data. The chart on the left is what was in the Lancet publication that the authors published. The chart on the right is what it should have looked like. Again, this is how they distort data. This is how they lie to you. This is the disinformation campaign that they're lodging against you. This is just such a clear example. It's scientific malfeasance. And I wrote to the Lancet, we did as the CO2 Coalition, and demanded that this paper be retracted. Of course, we never heard one thing from it. Isn't that just a great example of how they lie to you? And it wasn't very obvious either. You really had to dig into it. But that's what we're here for. Global deaths from natural disasters have declined nearly 98% since the early 1900s. And that's completely contrary to what you've been told. Now, granted, a lot of that has to do with things unrelated to climate change or global warming. A lot of it has to do with better reporting. For example, there's a Category 5 hurricane that's going to hit Galveston in 2 days. Evacuate now. And they didn't have that in 1918. Or the Doppler radar tells us, we're expecting tornadoes at 3 p.m. this afternoon. Get to your basements in Kansas or Oklahoma. So we have better reporting, better infrastructure, better homes to better withstand earthquakes, tornadoes, and the like. One other curious aspect here, the strongest tornadoes, EF3, EF4, EF5s, the really destructive tornadoes are declining. They just are. It's very clear. There's a discussion as to why they're declining. Does it really matter? They are. And you'll also find it's pretty interesting that the United States, you may not know this, more than 92% of the tornadoes throughout the world occur here in the United States. We're the tornado capital of the world, and that's because what causes tornadoes? It's usually warm, moist air below, and then cold air above it, and that causes their tornado and the cyclonic effect. And so we got this warm, moist air from the Gulf Coast that comes up into Kansas and Oklahoma. And then you'll have cold Canadian air coming down from Canada across the Rockies over top of that warm air, and it sets us up for these tornado alley, and that's why we have it. But the good news is they're declining, not increasing. And landfalling hurricanes, this is by decade, have been in decline. I took a look at each one of the Gulf Coast and Atlantic states, and only Mississippi had a slight increase in landfalling hurricanes. And bear in mind, landfalling hurricanes, we know every single landfalling hurricane that's occurred going back to 1850. We know because they're hard to miss if you have a hurricane. And so we know every one. And this is really good, accurate data. And it's what we should use. Now, you'll find that you'll hear during tornado season that named hurricanes have been increasing. And they have. But why is that? They're naming them earlier and smaller. And so because of that, they've increased the number of named tropical events. And here in Oregon, I hesitate to even put this up here about fires, but this was from the 4th National Climate Assessment. They had this chart of area burned in the United States showing just a huge increase in the area burned of fires in the United States. There was no source or reference. I went back and found it. Bear in mind, this chart starts in 1983. That's important. We'll see what that is. This is what the chart that it came from. They had data going back to 1926 that they did not. They cherry-picked the data. They started it in 1983. Why 1983? Because 1983 had the lowest number of both area burned and number of fires in the 20th century. So if you're going to start a chart and make it look bad, start it in 1983, and that's what they did. And so yes, has there been a slight increase in acreage burned in the United States? Yes, just not a whole lot. And what happened in 1983? In that time period, this was the Clinton administration. I'm probably telling you what you already know. At that point, we had a change in forest management policies, stopping controlled burns, stopping forestry, the spotted owl. We're going to have spotted owls. We have to save them. But now we know a lot of the spotted owls were actually being killed by the barred owls. And I know because I'm from Florida, and I live up against a jungle, and we have barred owls. I hear them every night out there talking to each other back and forth. It's a strange hoot that they've got, by the way. But anyhow, the point of the matter is fires. This is again a global study on fires. And they claimed our results suggest a notable declining rate of burned area globally. The Canadian Fire Service also sees the same thing, and they believe it was an increase of CO2 that's driving the decrease in fires in Canada. That's because CO2 increases means that trees don't have to transpire. Transpiration is lessened, so trees aren't, as they're transpiring, they're breathing in and out. They're not, as they breathe out, if you will, they expel water vapor. And because they don't have to do that so much, soil moisture is increased, they can withstand drought better. And again, in 2003, the Copernicus satellite went up, and finally, we have accurate measurements of area burned globally from satellites. And again, it also confirms a decrease in fires. Sea level is another item we talk about here, which it's one of my favorite subjects. But one of the things we already looked at glaciers retreating starting in the early 1800s. Well, we talk about sea level. Retreating glaciers and increasing sea level go hand in hand. And we see here too, sea level started rising again in the early 1800s, long before we started adding CO2 to the atmosphere. And the Maldives is an island chain in the Indian Ocean. According to the United Nations, it's the most at-risk island chain in the world. And it's going to be underwater within decades. And it's dangerous, and they're going to have to evacuate the islands, as they say of all the others. Was that really the case? 18,000 years ago, the Maldives were also just above sea level, just as they are today. in the last 18,000 years, sea level has risen 400 feet. What's your question you're going to ask me? Why are those islands not under 400 feet of water? Good question. It's because of a geologic process known as accretion. As sea level rises, these islands actually grow. And it's corals ring these islands. And corals grow really quickly. They can grow a foot a year or more. And they can keep up with very rapid increasing sea level. But how does it get up on the islands? And it's because during storm events, these corals are broken up. Actually, it's kind of interesting. Our latest children's book is called Foxy the Fruit Bat Sleeps Well. And it's about Foxy that lives on the island in one of the Maldives, and she can't sleep at night, or he can't sleep at night because he learned in school that his family and his home was in danger of being underwater. And so we're able to tell the story using science and facts about why Foxy should be able to sleep well. And it turns out parrotfish, actually, they eat the coral and they digest the polyps within the coral, and it comes in their mouth and goes out the back end. And so my grandson, he read the book and he was giggling because, 80% of the sand that rings these islands is actually parrotfish poop. So, little boys, they love that kind of, they love, parrotfish poop. And, but that's what it is. So the parrotfish eat it. It goes in one end, out the other. Storms break up the corals. The sands then, during storm events, the sands get washed up onto the beaches. Winds distribute it across the islands. Critters move it around, and the islands grow. So if the islands over the last 18,000 years weren't underwater after 400 feet of sea level rise. Sea level's rising at 7 inches per century. What they're telling you is 400 feet of sea level rise will put them underwater, but 400 didn't put them underwater, but 7 inches in the next century will. It's ludicrous. Also, there are 14 resort complexes and 4 airports being constructed on the Maldives right now, or just recently, worth tens of millions and more of dollars, insured by multinational insurance companies who avoid risk like the plague. And do you think those multinational insurance companies would insure these resorts if they thought it was going to be underwater anytime? Heck no. And you know that. It's just common sense. They're voting with their dollars. The biggest advantage is an increase in productivity. According to NASA, huge amounts of vegetation is increasing in every ecological niche, from the equator to the near polar regions. It's amazing. The other thing we need that's important is that increases in global food production is outpacing population growth. We have these people, this Malthusian idea that we have too much, we've got 8 billion people, we need to cull the population. And I always say, well, you go first, but we don't have anybody volunteering to cut their own. And so it's this idea, it's really what they're advancing is an anti-human philosophy. Again, crop production outpacing population growth. This is 4 of the largest crops globally. If we look here, blue is CO2, wheat, rice, corn, sugarcane, all breaking records year after year. And I could put up another 15 similar charts of other crops. These crops are breaking records because of increasing warmth, longer growing seasons, and more CO2 driving crop growth. This is corn production in black. You can see red is temperature, blue is CO2, and they're marching in lockstep. More corn, breaking records year after year after year. One of my favorites, if you get my book, is the strong relationship between human history and climate history. And we find that each of the warm periods were associated with great productivity. Food was bountiful, life was good. And it was a time of great prosperity during the warm periods. The cold periods were horrific. the first of the great warming periods associated with the first rise of the great civilizations. The Minoans, the Hittites, the Babylonians, the Harappan Empire in the Indus River Valley. All of these great civilizations rose up. And then they all collapsed within a period of 50 or 100 years when it started getting cold. Because each cold period was associated with crop failure, famine, pestilence, and mass depopulation. Completely opposite of what you're being told. Al Gore, Greta Thunberg, they would all call me a science denier. I would call them a history denier because they deny what history tells us. History tells us we should welcome the warmth and fear the cold. That's what history tells us. We have an education component. Our members came to me a number of years ago, said we're concerned about our children, grandchildren, great-grandchildren being indoctrinated into this climate cult. They're being taught groupthink and consensus science. They're not being taught the scientific method or critical thinking skills. And we did something about it. We've created a series of videos and books. All of them have lesson plans. We cater to the homeschool community and charter schools. Lagos down in Medford has our materials, the charter school down there. We went to the National Science Teaching Association's annual meeting. We went to the Belly of the Beast. They didn't like it because I created a report challenging the NSTA's position on climate change, and they didn't like it one bit. The next morning they showed up with their top dogs, kicked us out of the National Science Teaching Association's annual convention. They told me you need to remove your materials. And I said, go pound salt. And they said, no, you have to. And I said, then you have to leave. They kicked us out. And bear in mind, the two ladies on the left both have PhDs in chemistry. They're both, the lady on the far left is a AP science teacher, AP reader. She writes our lesson plans. They're probably the only two PhD scientists in the entire building, and they kicked us out. We went out with our heads held high. Tomorrow night, Sunday, we have a new documentary on Newsmax, 6 p.m. Pacific. Remember, write this down. I was part of this. Newsmax filmed a new documentary. It included Chris Wright, Department of Energy. You've seen him, he's everywhere. Dr. John Clauser, Nobel laureate. Steve Koonin, Obama's science director. Will Happer, our co-chairman. And yours truly. I'm not sure how I was involved with all those luminaries, but it's on 6 p.m. tomorrow. And we're hoping to have 60-second ads that will be aired along with the film. So Newsmax tomorrow, 6 p.m. it premieres. It looks, I've not seen it. I've seen clips of it, but it looks really good. And so if you like listening to me, you can hear me again tomorrow at 6. All right? And so with that, I will conclude. Just the one thing I want you to remember. Life is good and getting better. Warming and more CO2 are benefiting humanity and our ecosystem. So sleep well, there is no climate crisis.